A communications satellite or comsat is an artificial satellite sent to space for the purpose of telecommunications. Modern communications satellites use a variety of orbits including geostationary orbits, Molniya orbits, elliptical orbits and low Earth orbits. For fixed services, communications satellites provide a microwave radio relay technology complementary to that of communication cables. They are also used for mobile applications such as communications to ships, vehicles, planes and handheld terminals, and for TV and radio broadcasting. History. The Merriam-Webster dictionary defines a satellite as a celestial body orbiting another of larger size or a manufactured object or vehicle intended to orbit the Earth, the Moon, or another celestial body. Today's satellite communications can trace their origins all the way back to the Moon. A project named Communication Moon Relay was a telecommunication project carried out by the United States Navy. Its objective was to develop a secure and reliable method of wireless communication by using the Moon as a natural communications satellite. The first artificial satellite used solely to further advances in global communications was a balloon named Echo 1. Echo 1 was the world's first artificial communications satellite capable of relaying signals to other points on Earth. It soared 1,000 miles above the planet after its August 12, 1960 launch, yet relied on humanity's oldest flight technology, ballooning. Launched by NASA, Echo 1 was a giant metallic balloon 100 feet across. The world's first inflatable satellite, or Sataloon, as they were informally known, helped lay the foundation of today's satellite communications. The idea behind a communications satellite is simple: send data up into space and beam it back down to another spot on the globe. Echo 1 accomplished this by essentially serving as an enormous mirror 10 stories tall that could be used to bounce communications signals off of. The first American satellite to relay communications was Project SCORE in 1958. Which used a tape recorder to store and forward voice messages. It was used to send a Christmas greeting to the world from U.S. President Dwight D. Eisenhower. NASA launched the Echo satellite in 1960. The 100-foot aluminized PET film balloon served as a passive reflector for radio communications. Courier 1B, built by Philco, also launched in 1960, was the world's first active repeater satellite. It is commonly believed that the first communications satellite was Sputnik 1. Put into orbit by the Soviet Union on October 4, 1957, it was equipped with an onboard radio transmitter that worked on two frequencies, 20.005 and 40.002 MHz. Sputnik 1 was launched as a step in the exploration of space and rocket development. While incredibly important, it was not placed in orbit for the purpose of sending data from one point on Earth to another. Hence, it was not the first communications satellite, but it was the first artificial satellite in the steps leading to today's satellite communications. Telstar was the first active, direct relay communications satellite. Belonging to AT&T as part of a multinational agreement between AT&T, Bell Telephone Laboratories, NASA, the British General Post Office, and the French National PTT to develop satellite communications, it was launched by NASA from Cape Canaveral on July 10, 1962, the first privately sponsored space launch. Relay 1 was launched on December 13, 1962, and became the first satellite to broadcast across the Pacific on November 22, 1963. An immediate antecedent of the geostationary satellites was HughesSynchron 2, launched on July 26, 1963. Syncon 2 revolved around the Earth once per day at constant speed, but because it still had north-south motion, special equipment was needed to track it. Geostationary orbits. To an observer on the Earth, a satellite in a geostationary orbit appears motionless, in a fixed position in the sky. This is because it revolves around the Earth at the Earth's own angular velocity. A geostationary orbit is useful for communications because ground antennas can be aimed at the satellite without their having to track the satellite's motion. This is relatively inexpensive. In applications that require a large number of ground antennas, such as direct TV distribution, the savings in ground equipment can more than outweigh the cost and complexity of placing a satellite into orbit. The concept of the geostationary communications satellite was first proposed by Arthur C. Clarke, building on work by Konstantin Tsikovsky and on the 1929 work by Hermann Potowanik Das Problem der Befahrung des Weltraums der Raketenmotor. In October 1945 Clarke published an article titled Extraterrestrial Relays in the British magazine Wireless World. The article described the fundamentals behind the deployment of artificial satellites in geostationary orbits for the purpose of relaying radio signals. Thus, Arthur C. Clarke is often quoted as being the inventor of the communications satellite. The first geostationary satellite was SYNCOM-3, launched on August 19, 1964, and used for communication across the Pacific, starting with television coverage of the 1964 Summer Olympics. Shortly after SYNCOM-3, Intelsat I, also known as Early Bird, was launched on April 6, 1965 and placed in orbit at 28° west longitude. It was the first geostationary satellite for telecommunications over the Atlantic Ocean. On November 9, 1972, Canada's first geostationary satellite serving the continent, Anik A1, was launched by Telstar Canada, with the United States following suit with a launch of Star 1 by Western Union on April 13, 1974. On May 30, 1974, the first geostationary communications satellite in the world to be three-axis stabilized was launched, the experimental satellite ATS-6 built for NASA. After the launches of the Telstar through Star 1 satellites, RCA Americom launched SATCOM-1 in 1975. It was SATCOM-1 that was instrumental in helping early cable TV channels such as WTBS, HBO, CBN and the Weather Channel become successful, because these channels distributed their programming to all of the local cable TV audience using the satellite. Additionally, it was the first satellite used by broadcast television networks in the United States, like ABC, NBC, and CBS, to distribute programming to their local affiliate stations. SATCOM-1 was widely used because it had twice the communications capacity of the competing Star 1 in America, resulting in lower transponder usage costs. Satellites in later decades tended to have even higher transponder numbers. By 2000, Hughes Space and Communications had built nearly 40% of the more than 100 satellites in service worldwide. Other major satellite manufacturers include Space Systems Loral, Orbital Sciences Corporation with the Starbar series, Indian Space Research Organization, Lockheed Martin, Northrop Grumman, Alcatel Space, now Thales Alenia Space, with the Spacebo series, and Astrium. Low Earth orbiting satellites. A low Earth orbit typically is a circular orbit about 200 kilometers above the Earth's surface and, correspondingly, a period of about 90 minutes. Because of their low altitude, these satellites are only visible from within a radius of roughly 1,000 kilometers from the sub-satellite point. In addition, satellites in low Earth orbit change their position relative to the ground position quickly. So even for local applications, a large number of satellites are needed if the mission requires uninterrupted connectivity. Low Earth orbiting satellites are less expensive to launch into orbit than geostationary satellites and, due to proximity to the ground, do not require as high signal strength. Thus there is a trade-off between the number of satellites and their cost. In addition, there are important differences in the onboard and ground equipment needed to support the two types of missions. A group of satellites working in concert is known as a satellite constellation. Two such constellations, intended to provide satellite phone services, primarily to remote areas, are the Iridium and Globalstar systems. The Iridium system has 66 satellites. It is also possible to offer discontinuous coverage using a low Earth orbit satellite capable of storing data received while passing over one part of Earth and transmitting it later while passing over another part. This will be the case with the Cascade system of Canada's Cassiope communications satellite. Another system using this store and forward method is Orbcom. Molniya satellites. Geostationary satellites must operate above the equator and therefore appear lower on the horizon as the receiver gets the farther from the equator. This will cause problems for extreme northerly latitudes, affecting connectivity and causing multipath. For areas close to the North Pole, a geostationary satellite may appear below the horizon. Therefore Molniya orbit satellites have been launched, mainly in Russia, to alleviate this problem. The first satellite of the Molniya series was launched on April 23, 1965 and was used for experimental transmission of TV signal from a Moscow uplink station to downlink stations located in Siberia and the Russian Far East, in Norilsk, Khabarovsk, Magadan and Vladivostok. In November 1967 Soviet engineers created a unique system of national TV network of satellite television, called Orbiter, that was based on Molniya satellites. Molniya orbits can be an appealing alternative in such cases. The Molniya orbit is highly inclined, guaranteeing good elevation over selected positions during the northern portion of the orbit. The Molniya orbit is designed so that the satellite spends the great majority of its time over the far northern latitudes, during which its ground footprint moves only slightly. Its period is 1/2 day, so that the satellite is available for operation over the targeted region for 6 to 9 hours every second revolution. In this way a constellation of 3 Molniya satellites can provide uninterrupted coverage. Structure: communications satellites are usually composed of the following subsystems: communication payload, normally composed of transponders, antenna, and switching systems, engines used to bring the satellite to its desired orbit, station keeping tracking and stabilization subsystem used to keep the satellite in the right orbit, with its antennas pointed in the right direction, and its power system pointed towards the sun, power subsystem, used to power the satellite systems, normally composed of solar cells, and batteries that maintain power during solar eclipse, command and control subsystem, which maintains communications with ground control stations. The ground control Earth stations monitor the satellite performance and control its functionality during various phases of its life cycle. The bandwidth available from a satellite depends upon the number of transponders provided by the satellite. Each service requires a different amount of bandwidth for transmission. This is typically known as link budgeting, and a network simulator can be used to arrive at the exact value. Applications: telephone. The first and historically most important application for communication satellites was in intercontinental long-distance telephony. The fixed public switch telephone network relays telephone calls from landline telephones to an Earth station, where they are then transmitted to a geostationary satellite. The downlink follows an analogous path. Improvements in submarine communications cables, through the use of fiber optics, caused some decline in the use of satellites for fixed telephony in the late 20th century. Satellite communications are still used in many applications today. Remote islands such as Ascension Island, St. Helena, Diego Garcia, and Easter Island, where no submarine cables are in service, need satellite telephones. There are also regions of some continents and countries where landline telecommunications are rare to non-existent, for example large regions of South America, Africa, Canada, China, Russia, and Australia. Satellite communications also provide connection to the edges of Antarctica and Greenland. Other land use for satellite phones are rigs at sea, a backup for hospitals, military, and recreation. Ships at sea often use satellite phones, and planes. Satellite phones can be accomplished in many different ways. On larger scale often there will be local telephone system in the isolated area with a link to a telephone system in a mainland area. There are services that will patch a radio signal to a telephone system. In this example most any type of satellite can be used. Satellite phones connect directly to a constellation of either geostationary or low Earth orbit satellites. Calls are then forwarded to a satellite teleport connected to the public switched telephone network. Television. As television became the main market, its demand for simultaneous delivery of relatively few signals of large bandwidth to many receivers being a more precise match for the capabilities of geosynchronous comsats. Two satellite types are used for North American television and radio: direct broadcast satellite, and fixed service satellite. The definitions of FSS and DBS satellites outside of North America, especially in Europe, are a bit more ambiguous. Most satellites used for direct-to-home television in Europe have the same high-power output as DBS-class satellites in North America, but use the same linear polarization as FSS-class satellites. Examples of these are the Astra, Eutelsat, and Hotbird spacecraft in orbit over the European continent. Because of this, the terms FSS and DBS are also used throughout the North American continent, and are uncommon in Europe. Fixed-service satellites use the C-band, and the lower portions of the Ku bands. They are normally used for broadcast feeds to and from television networks and local affiliate stations, as well as being used for distance learning by schools and universities, business television, video conferencing, and general commercial telecommunications. FSS satellites are also used to distribute national cable channels to cable television head ends. Free-to-air satellite TV channels are also usually distributed on FSS satellites in the Ku band. The Intelsat Americas 5, Galaxy 10R and AMC-3 satellites over North America provide a quite large amount of FTA channels on their Ku band transponders. The American Dish Network DBS service has also recently utilized FSS technology as well for their programming packages requiring their Super Dish antenna, due to Dish Network needing more capacity to carry local television stations per the FCC's must-carry regulations, and for more bandwidth to carry HD TV channels. A direct broadcast satellite is a communications satellite that transmits to small DBS satellite dishes. Direct broadcast satellites generally operate in the upper portion of the microwave Ku band. DBS technology is used for DTH-oriented satellite TV services, such as Direct from Dish Network in the United States, Bell TV and Shaw Direct in Canada, Freesat and Sky in the UK, Ireland, and New Zealand, and DSTV in South Africa. Operating at lower frequency and lower power than DBS, FSS satellites require a much larger dish for reception in diameter for Ku band, and 12 feet or larger for C-band. They use linear polarization for each of the transponders RF input and output, but this is a minor technical difference that users do not notice. FSS satellite technology was also originally used for DTH satellite TV from the late 1970s to the early 1990s in the United States in the form of TVRO receivers and dishes. It was also used in its Ku-band form for the now-defunct Primestar satellite TV service. Some satellites have been launched that have transponders in the Ka band, such as Direct Spaceway 1 satellite, and Anik F2. NASA and ISRO have also launched experimental satellites carrying Ka band beacons recently. Some manufacturers have also introduced special antennas for mobile reception of DBS television. Using Global Positioning System technology as a reference, these antennas automatically re-aim to the satellite no matter where or how the vehicle is situated. These mobile satellite antennas are popular with some recreational vehicle owners. Such mobile DBS antennas are also used by JetBlue Airways for direct, which passengers can view on board on LCD screens mounted in the seats. Digital cinema. Realization and demonstration, on October 29, 2001, of the first digital cinema transmission by satellite in Europe of a feature film by Bernard Porkn and Philippe Einant. Radio. Satellite radio offers audio services in some countries, notably the United States. Mobile services allow listeners to roam a continent, listening to the same audio programming anywhere. A satellite radio or subscription radio is a digital radio signal that is broadcast by a communications satellite, which covers a much wider geographical range than terrestrial radio signals. Satellite radio offers a meaningful alternative to ground-based radio services in some countries, notably the United States. Mobile services, such as SiriusXM and WorldSpace, allow listeners to roam across an entire continent, listening to the same audio programming anywhere they go. Other services, such as Music Choice or Muzak's satellite-delivered content, require a fixed location receiver and a dish antenna. In all cases, the antenna must have a clear view to the satellites. In areas where tall buildings, bridges, or even parking garages obscure the signal, repeaters can be placed to make the signal available to listeners. Initially available for broadcaster stationary TV receivers, by 2004 popular mobile direct broadcast applications made their appearance with the arrival of two satellite radio systems in the United States, Sirius and XM Satellite Radio Holdings. Later they merged to become the conglomerate Sirius XM. Radio services are usually provided by commercial ventures and are subscription-based. The various services are proprietary signals, requiring specialized hardware for decoding and playback. Providers usually carry a variety of news, weather, sports, and music channels, with the music channels generally being commercial-free. In areas with a relatively high population density, it is easier and less expensive to reach the bulk of the population with terrestrial broadcasts. Thus in the UK and some other countries, the contemporary evolution of radio services is focused on digital audio broadcasting services or HD radio, rather than satellite radio. Amateur radio operators have access to the amateur radio satellites that have been designed specifically to carry amateur radio traffic. Most such satellites operate as spaceborne repeaters, and are generally accessed by amateurs equipped with UHF or VHF radio equipment and highly directional antennas such as Yagis or dish antennas. Due to launch costs, most current amateur satellites are launched into fairly low Earth orbits, and are designed to deal with only a limited number of brief contacts at any given time. Some satellites also provide data forwarding services using the X25 or similar protocols. Internet access. After the 1990s, satellite communication technology has been used as a means to connect to the Internet via broadband data connections. This can be very useful for users who are located in remote areas, and cannot access a broadband connection, or require high availability of services. Military communications satellites are used for military communications applications, such as global command and control systems. Examples of military systems that use communication satellites are the MILSTAR, the DSCS, and the FLTSATCOM of the United States, NATO satellites, United Kingdom satellites, and satellites of the former Soviet Union. India has launched its first military communications satellite GSAT-7, its transponders operate in UHF, F, C and Ku-band bands. Typically military satellites operate in the UHF, SHF or EHF frequency bands. See also, broadcasting satellite, commercialization of space, computation of radio wave attenuation in the atmosphere, ComSat, data transmission network, G-Cipher2, digital video broadcasting, free space optical communication, integral SATCOM initiative, Sputnik, list of communication satellite companies, list of communications satellite firsts, list of orbits, PanAmSat, Project West Ford, reconnaissance satellite, satellite space segment, SatModem, Symphony, VSAT, WorldView satellite constellation, references. External links, Satellite Industry Association, European Satellite Operators Association, Sat Magazine, Sat News, Satellite press releases. The Future of Communication Satellite Business, Communications Satellites Short History by David J. Hallen, Beyond the Ionosphere, 50 Years of Satellite Communication, Lloyd's Satellite Constellations, Satcom Online, an overview of satellite operating frequencies and their applications, Telecommunications Satellite, by copyright.